Alright, we're going to do 3.0 number 7. Our scale here is 0.5 centimeters for 1 meters per second squared. So acceleration, and it is a vector quantity, so that means we have a magnitude and a direction. And we're going to do these graphically. So graphically, we're going to draw our first one, and then we're going to tip to tail add each one after the other. So 5 meters per second at 270. We're going to scoot down quite a bit on the paper to draw this one. So our 0 once again is to the right, 90, 180, and then to get 270, 180, 270, 360. So our 270 is straight down the paper here. So we go like that. At our scale, 5 meters per second squared would be 2.5. So this vector represents 5 meters per second squared at 270. So straight down the paper at 270. Our second vector is 10 meters per second squared at 60 degrees. We're going to add this to the tip of that vector. So 60 degrees, our 0 is still to the right. Measure our direction, and then we're going to put our magnitude in. So our magnitude at our scale is 5. So we draw it to just there. And put the tip in. Alright, so that is the first vector plus the second. If we were to draw the resultant here, it would go from here to there. But since we're adding 3, we're going to put this one onto the tip of the last one we drew. So 15 meters per second squared at 120 degrees. So we start measuring from the tip of the last one. Our 0 is right over here. And 120 we measure from 0, 90, 120. So it will be up in this direction here. Okay. So from the tip that way, at our scale would be 7.5. So we're going to draw the magnitude in. Tip 7.5. Be right there. Okay. So our resultant would be from where we started to where we ended. Okay. So it's going to go from here to there. Let's draw it in. If we look, we can go ahead and measure about 8.5 centimeters. So at our scale, we'll just double this, which gives us 17 meters per second squared. That's our magnitude of our resultant. And I drew my vector going the wrong way. Alright, so where we started to where we ended. So our resultant would be from here to there. Okay, so our direction now is measured from 0. So from where we started, our 0 is over here. We get about 98, 99. We'll say 99 at 99 degrees. If we were to measure this from our north, south, east, west, our 90 degrees would be our northern axis. And so we're 9 degrees west, because we're to the left, west of north.